So let's find the probability of an event. 12-sided dice, as shown in this figure to the right, can be constructed in the shape of regular dodecahedrons, such that each of the numbers from 1 to 6 occurs twice on each die. Show that these dice can be used in any game requiring ordinary 6-sided dice without changing the probability of the various events. So if we have a 6-sided dice, 6-sided die, rolling any number, we could get, any number is 1 out of 6 chance. It doesn't matter what it is, right? Just any number. Now, one 12-sided die, or dice, you could have, there's 2 chances, right? So the number expected, the equally likely outcomes is 2 out of 12 sides, right? So if there's 2 of each number on the 12-sided die, like there's 2 1s, 2 2s, and so forth, then you have 2 out of 12 chance of rolling it, which is the same 1 out of 6. So try this. Show that the probability of drawing a club at random from a standard deck of 52 playing cards is the same as the probability of drawing the ace of hearts at random from a set of 4 cards consisting of the ace of hearts, diamonds, clubs, and spades. So first we note that the probability of drawing a club, there are 52 cards and there are 13 clubs, so therefore there's 1 in 4 chance. Now if we had only 4 cards, so probability of an ace of hearts, so our sample space, we only have 4 cards, and then if all aces are in there, then you have 1 in 4 chance of drawing an ace as well. Let's look at random selection. The figure shows the numbers of degree-granting post-secondary institutions in various regions of the United States in 2015. What's the probability that an institution selected at random is one of the 3 southern regions? So the 3 southern regions are down here, west, south central, east, south central, and south Atlantic. So first we need to total the number of institutions there are. And so if you add all these values here, that total institutions, that total is 4,622, right? So you just add all of these numbers here to get that 4,622. So the 3 southern regions, I'll just say south regions, so you total that number, so that's going to be 451 plus 302 plus 858, so that's going to be 1,611. So the probability of the event with the number of expected likely outcomes over the number of the sample space, that is 1,611 over the total, which is 4,622, which is approximately 0.349. So with that example here, what's the probability that an institution selected at random is in the Pacific region? So see if you can figure that out. What is the probability that it's in the Pacific region? So I'm hoping with the Pacific region you see that it's just 640, so that would be 640 over the total institutions, and then if you were to use a calculator, that would be 0.138. Example 6, finding the probability of winning a lottery. In Arizona's The Pick Game, a player chooses 6 different numbers from 1 to 44. If these 6 numbers match the 6 numbers drawn in any order, the player wins or shares the top prize. What's the probability of winning the top prize when the player buys 1 ticket? So there are 44 different numbers, so 44, and you need to pick a perfect 6, right? That's how that's going to work. So we're using combinations here. So this is going to be 44 factorial over 44 minus 6 factorial times 6 factorial. And then so 44 factorial over 44 minus 6 is 38 factorial times 6 factorial. So 44 times 43 times 42 times 41, 40, 39, 38 factorial over 38 factorial, 6 times 4 times 3 times 2 times 1 6 times 5 times 4 times 3 times 2 times 1. And then you simplify, right? So it's just trying to figure out, using the formula, getting the answers here. And so what you would get is, after you figure out what this combination is, you would get 7,059,000 and 52. But the probability of the event, right? There's only one way that could happen, and so that's 1 over 7,059,000 and 52. So try this example. Pennsylvania's Cash 5 game, a player chooses 5 different numbers from 1 to 43. If these 5 numbers match the numbers drawn in any order, the player wins or shares the top prize. What's the probability of winning the top prize when the player buys 1 ticket? So try this example here. So trying this out, you're using combinations again. So it's 43, and they have to choose 5 exactly. So you would get 1 over 962,000 over 598. So a little better than the previous one that was there, but still really difficult to do.